Hey everybody, this is 7.3, Solving Systems by Substitution. Today is day one. We're going to be learning how to do this, or I guess reminding you how to do this when we have a line and a quadratic. So you know how to do all of the things that we're covering. You've all done it before. It's just we're kind of bringing things together. So you've done problems like this last year when we had two linear equations, being able to solve by substitution. In effect, all we do, well, I'll leave that to you. If you want to give that a try, go for it. But we're going to just spend the time focusing on the type of problems that you'll run into on the homework and on the test. Okay, so setting up, these are the steps on how to do that. You're welcome to use that whenever you want. But let's just go straight into a problem. So, today is solving by substitution, so we're going to be substituting something. Okay, so if you ever have two equations, if one of them is solved for one of the variables, then we can always plug the right side into the other equation. So we know that y is equal to negative 3x plus 12. And look at that, our other equation has a y. So we can substitute that in for y. In effect, we're just really setting them equal to each other. So we know that negative 3x plus 12 is equal to x squared minus 11x plus 28. And when they're equal to each other, then that should be where they intersect. Okay? So that's our first step, is setting them equal to each other, or we substitute one equation into the other equation. Okay? So your next step is we are going to want to solve these equations. And these are quadratics. If you see, we have an exponent of 2, which means that we could use any of the methods that we used in the past. So if we could solve by factoring, completing the square, or the quadratic formula. I'm going to leave that up to you, but for all of these examples, I'm going to use factoring. So all of the problems, you should be able to factor them. So if we want to solve, we have to have it in standard form. We have to have everything on one side, and one of the sides has to be equal to 0. So we need to move all of this over to the other side. So how do we do that? Again, we're going to use their opposites, the inverse. It's a negative 3, so we're going to add 3x. So we'd add 3x to both sides, and we'd need to subtract 12 to both sides. Again, we can only combine like terms that are on like the same, combine like terms if they have the same variable. So we can't add 3x to x squared, right? Okay, so we move those over, and we end up getting 0 equals x squared minus 8x plus 16. Okay, so now we're all set up in order to solve. Okay, again, you can choose the method you'd like, but I'm going to do factoring. So we need to figure out what multiplies to 16, x squared, and adds to negative 8x. And hopefully it comes to you, maybe something like, gosh, I don't know why it's not coming to me. So 16, you could do 4 and 4. Yeah, 4 and 4. So we could do negative 4 and negative 4. That would give us negative 8. All right. Now we got to ask, can we use the shortcut? And we can, because a is 1. That leading coefficient is 1. So we can go and do our shortcut. So again, it's always x, and then whatever the numbers are for our puzzle that we did. So we got x minus 4, and then the other would be x minus 4. So they're the same. Okay? Now we have two things that are being multiplied by, and they're equal to 0, which means that either this has got to be equal to 0 or this has got to be equal to 0. So this is where we do the zero product property. Okay, so what does x need to be to make that be 0? Well, x would have to be 4. And it would have to be the same for the other side, okay? If they're both the same, then you don't really need to do the other side. So now we have our x. If we remember when in our last lesson we graphed, and we would write our, where they intersect was an ordered pair. So we have the x, and we need to find the y. Okay? If you have an x and you need to find a y, if you have an x and need a y, what do? Well, we can substitute. Okay, we can substitute it into either of these equations. So if we look at these two equations, I mean, we're solving where they meet each other. At that point, no matter what equation, no matter what x, whatever x is into either of those equations should give us the same y value, because they intersect. Okay, hope that makes sense. If not, come and talk to me. All right, and then so I guess what I'm saying is that we can plug that x. Here it's 4. We can plug it into that equation to find y. All right, so y is equal to -3 times x, but x now is 4 plus 12, and that gives us 0. So we know our solution is 4, 0. Okay, we'll do another example of that. So that's our answer. It only crosses each other one time. Okay, so let's do B. Same sort of thing, but there's something that's a little different. So again, we want to set them equal to each other. So just to kind of save some time, I'm not going to write that. I'm just going to write the other equation on the other side. Okay, and then we need to get everything on one side. So we'll subtract x, and we'll add 1, and we'd get 2x squared plus 12x plus 16 is equal to 0. So if you remember, whenever we were factoring, we always wanted to see if we could take out the greatest common factor. So if you look at these first 3 terms, that they are all divisible by 2. All right, and we would factor out that 2, but when we're solving, we can always just divide both sides by the greatest common factor, and then we don't have to worry about it. We don't have to carry it around, and it just makes it easier for us. Okay, so always see if there's a greatest common factor and divide it out. So now that's really kind of the new thing about this one, but we'll finish it up. So it needs to multiply to 8x squared and adds to 6x. So maybe 4 and 2. Again, because we took out the greatest common factor, now a is 1. So we can use the shortcut, x plus 4 and x plus 2. Oops, just moved. All right, so now we got to figure out what x needs to be to make this be 0. So x would have to be -4, or for the other binomial, x would have to be -2. So we have our 2 x's. We need to find our y's that go with them. So again, we want to use the easier equation. We'll probably use y equals x minus 1. And we're going to plug those in. So y equals -4 minus 1 gives us -5. So that's one of our ordered pairs would be -4, -5. and then we'll do it for the other. So that gives us -3. So -2 comma -3. So in this example, we have two intersections, so it crosses each other for these two equations 2 times. All right. Let's look at F. I think the only thing here that's different that you need to make sure is that this is just +0. So when you set it over, set them equal to each other, just don't be surprised when there's nothing to add to. You can always do a +0 if you wanted to. But besides that, so we get x squared minus 5x plus 4, and then we do the same thing. So nothing really surprised there. But F, let's make sure we get this one. So same thing, we set them equal to each other. We would subtract 2x to both sides and add 1 to both sides. Cross, cross. So 2x squared plus 1x minus 3 has got to be equal to 0. Okay, so as you notice here, a is not equal to 1. So we can't use the shortcut here. There's no greatest common factor. We can't factor out a 2. So this is where we're going to need to use the box. So if you weren't here, or if you did it a different way in a different class, just come and talk to me. Alright, so what we did is we still need to find the two things that multiply. So again, what multiplies to -6x squared. So we just multiply these two together. And needs to add to the middle term. So for here, it looks like we'd have to maybe do 3 and 2. Maybe a +3 and a -2 could make that work. So here, again, we can't just go to this point. I'm going to write this down and then I'm going to cross it off because we can't do that. If you were to distribute that back, the x and the x wouldn't give us 2x squared. It would just give us x squared. So we can't use the shortcut. Okay, so if you remember what we did is we used a box that's 2 by 2. We have the first term, which is 2x squared. Our next term, rather than writing down 1x, we're going to break it into the two parts that we found. So 3x and a minus 2x. And then we have our constant minus 3. Okay, so again, this goes from here. These two gives us those two boxes. And then that constant gives us the last box. Okay, I know it's a little crazy, but oops, leave that there. Okay, so after that, we would take out the greatest common factor for each row and column. So for the first row would be a 2 and an x, -1. Nope, yep, -1. Sorry, I messed that up. Go back. Greatest common factor here is just x and -1. This is where we have the 2x and the 3. Okay, so we get 2x plus 3 and x minus 1. So that's the factoring part. And now we're back to where we were before. We have two binomials. We need to figure out what does x need to be for the whole thing to be 0. So let's start on the right side because that's the easier one. X would have to be 1. If we plug that in here, we would get 0. For the other, what I would recommend is that you would set it equal to 0 and then solve. So we would subtract 3 from both sides. So we'd get -3. And then we would divide both sides by 2. So we end up getting -3/2. Or -1.5, whichever you prefer. Okay, so that's kind of the tricky part here. Again, 2x plus 3 has got to be equal to 0. Would subtract 3, and then we'd divide both sides by 2. And that's where we come up with that -2/3. All right. Okay, so now we've got our x's. Again, you could start your ordered pair, would get negative 3/2, comma something, and 1 comma something. Again, to find the y's, we plug it into the easier of the two equations, so 2x minus 1. So y equals 2x minus 1. So we'll plug that in. So y is equal to 2 times negative 3/2 minus 1. The 2's will cancel, and we just get negative 3 minus 1 gives us negative 4. And then we'll do it for the other, so y equals 2 times 1 minus 1, which gives us 2 minus 1, which is 1. So those are our two solutions. Okay, if you have any questions, please let me know. I know it's a little tricky, a lot of work. Holy moly, that's a lot of work, but you can do it. I believe in you. If you need help, please come and ask. For those story problems, letter A, I'm just going to leave that. If you want to look at it, basically we come up with the two equations and two unknowns. So they tell us the area needs to be a certain value, 48. We know that area is length times width, so we can set up our equation, one of our equations. And then the other equation, they say that length has to be 2 feet less than the width. So length is the width times 2. So we have two equations, two unknowns. What we do is we substitute that into our first equation. Okay, and that's what we have here, this box. And then we just need to get it in standard form. So one thing we need to do is move everything to one side. So I subtracted 48 from both sides. And then also we wanted to get rid of the parentheses, so we distribute the width, the w, and we get w squared minus 2w. So now it's in standard form, and you're doing the same thing that you did before. Find the two things that multiply and add. We can write down our binomials and then solve. Okay, so not much different. You just have to come up with the equations. B is more like what you're going to see on your homework. Okay, it says that perimeter of a rectangle is 22 centimeters. Okay, so what is perimeter? And you'd probably say, oh, Mr. Warner, I know what that is. Perimeter is just the length of the sides. So we have length and width, which means we have another length and another width, and we're just going to add all those up. So perimeter is two lengths, or length plus length, L plus L is 2 L's, and then width plus width is 2 widths. So basically that's the equation that we'll use. And then it also tells us that we have area. So area is length times width. Okay, so we plug in what we know. So 22 is equal to 2L plus 2W. And area is 28, which is length times width. Alright, before we do anything else, we should probably simplify it if possible. So if we look at the left side, it looks like we could divide everything by 2. So 11 is equal to length plus width. Okay, so this is something that we could look at for a minute and see if there's something that looks familiar. So it looks like we have two things being multiplied to give us a number, and we have the same two things that are being added to, and that gives us a number. So that should look very familiar to the puzzle that we do every time we factor. So what are the two numbers that have to multiply to give us 28 and add to 11? And you'd probably say, 7 and 4. So length could be 4 and width could be 7. Doesn't really matter which is which. Okay, so that's probably how I would do it. I feel like that's probably the quickest way to do it. Another way to do that is what you'd have to do, kind of like what we did up here. You'd need to solve this equation for L or for W, and then plug it into this equation. And then we could get it in standard form and do glasses. And when you do glasses and find the two things that multiply and add, what do you know? These are actually the same thing that you'll write down anyways. So this is just kind of like a little shortcut, but you end up getting the same thing. Okay? If you have any questions, please let me know. I'd love to help. Come get some help during lunch or after school. All right, we'll see you later.